All right, let's get into it. Have you ever wondered how scientists manage to create those perfectly mixed solutions every single time? It's not some kind of magic, it's pure chemistry. And today, we're going to unlock the secret recipe they all use: molarity and dilution.
It all really boils down to one simple but absolutely critical question. How do you measure concentration? How can you be certain exactly how much of one thing is mixed into another?
And trust me, this is not just some abstract problem for a textbook. In the real world, like in medicine, getting the concentration of a solution right is literally a matter of life and death. If you have too much or too little of a substance in an IV drip, well, that can have incredibly serious consequences. So, how do they nail it every single time? Well, to answer that, we need a really precise tool for measuring concentration. And in the world of chemistry, that tool has a name: molarity. You can think of it as the gold standard, the universal unit for figuring out the strength of any solution.
Okay, but before we get ahead of ourselves, let's do a quick refresh on what a solution even is. It's just a fancy term for a completely uniform mixture. So think about dissolving salt in water. Once it's stirred, you can't see the individual salt grains anymore, right? It's all one thing. That is a solution. And every single solution breaks down into two key players. The stuff that gets dissolved, like the salt in our example, that's called the solute. And the stuff that does the dissolving, the water, is the solvent. It's pretty easy to remember. The solute is what you put in, and the solvent is what you put it into. Which brings us to the star of our show, molarity. So the official definition is the number of moles of solute dissolved in 1 liter of solution. Now that word mole might sound a little weird, but just think of it like a chemist's dozen. It's just a specific, super large number of molecules. And the reason chemists use it is because what really matters for reactions is the number of particles, not just their weight. So molarity is basically the ultimate strength rating for any chemical mix. All right, so we know what it is. Now for the fun part. Let's actually see how we can use molarity to whip up that perfect mix we've been talking about. And you know what? It's a surprisingly simple 3-step process. First, you got to figure out how many moles of your solute you have. Second, you need the total volume of your solution, and you have to make sure it's in liters. And third, you just divide the moles by the liters. That's it, seriously. Let's actually watch those steps in action. Say we want to make a 1 molar saline solution. We'd start with 58.44 grams of table salt. Now, thanks to the periodic table, we know that mass is exactly 1 mole of salt. So step 1, done. Next, we dissolve that salt into enough water to make a final volume of exactly 1 liter. Step 2, check. And finally, for step 3, we just do the math. 1 mole divided by 1 liter gives us a perfect 1 molar solution. See? Not so scary. Okay, great. We can make a solution from scratch. But what if you have a solution that's already made, but it's just way too strong? Well, you don't throw it out. You use the elegant art of dilution. And dilution is exactly what it sounds like. We've all done this. Think about making coffee, and it comes out way too strong, almost syrupy. What do? You add a little more hot water, the solvent, to weaken it until it's just right. It's the exact same idea in a chemistry lab, just with a bit more precision. And the secret to getting that precision is this beautiful, simple formula. M1V1 equals M2V2. Here, M is for molarity, and V is for volume. All this formula is saying is that the concentration times the volume of your starting solution, your before, is always going to be equal to the concentration and volume of your final, diluted solution, your after. This little equation is the key to perfect dilution. So let's put it to work. Imagine we have 100 milliliters of a 2-molar acid. That's our M1 and V1, our before. We want to dilute it until we have a final volume of 500 milliliters. That's our V2. We're looking for the new concentration, our M2. All we have to do is plug in the numbers we know, do a tiny bit of algebra, and there we go. 0.4 molar, a perfect dilution, all thanks to that simple formula. So we've got the theory down, we've got the math down, but this stuff isn't just for a lab or a classroom. Let's take a look at where molarity and dilution pop up all around us every single day. Molarity is, and I mean this, everywhere. It's in medicine, making sure those IV solutions and drug doses are safe and effective. It's in the food and beverage industry, perfecting the sugar concentration to get the taste of your favorite soda just right. Environmental scientists are using it constantly, measuring pollutants in water to make sure they're at safe levels. And of course, in any lab on Earth, it's the absolute bedrock for making sure chemical reactions work the way they're supposed to. I love this quote because it just brings everything crashing back down to earth in the simplest, most perfect way. Molarity is just the sweetness of the juice. Dilution is just adding water because it's a little too sweet. We have all done this. We were all little chemists in the kitchen and didn't even know it. So, the next time you're making coffee or sweetening your tea or even just watering down some juice, remember the powerful chemistry that's at play. Now that you're in on the chemist's big secret of concentration and dilution, what everyday mixture are you going to see in a completely new light?